Did I get this counting right? It's a hard thing to say, and I don't like to say it. Write that down there. Asymptotes, I think it is best pronounced.
No, I just have to take in high school.
If you're looking in the book, 78. The subheading is graphing rational functions. And more specifically, things that look a little like this. Let's graph this just for fun. Y equals, these are not linear equations, by the way.
No, they're
2 over x 2 over x minus 8 plus 1. We're just going to plot. We're going to plot this one, but you won't have to in the future because I'll just ask you to sketch it out. It's a pretty simple little procedure here. We're going to do this one actually by making a table. And when you make the table, the beauty of this is you can pick any values of x that you want, so you can pick some easy ones. So
9, 8.
well, I would pick numbers that's going to give us some easy numbers to work with. For
10.
example, 10. 10 would be a great one because if you did 10, 10 minus 8 is 2. 2 over 2 is 1. 1 plus 1 is 2. What would give us a 1 on the bottom? 9, right? You do 9. 9 minus 8 is 1. 2 over 1 is 2. 2 plus 1 is 3. If I did, what else could I do that would make some sort of sense?
8.
Huh?
8, 7.
No, there's the deal.
-10.
If you do 8, children, you get a 0 on the bottom of a fraction, and you can't do it. So this, you cannot pick 8, and that's going to be important here in just a minute. So 8 is not a number you could use.
7. -10.
Well, the problem is if you start doing negatives here, we're going to get fractions, which we can do. Let's do that. Let's do a negative number. Let's do, yeah, -6. No, yes. No, let's not do that. Let's do negative. What's going to be something on the bottom? -2. If you do -2, you get -2 and a -8 is a -10, so you get -1/5. -1/5 plus 1 is actually 4/5. We can deal with some fractions. What if I did -1? Yeah. No, let's do -4. -4, if you did -4 here, you get -12, so you get -1/6 plus 1 is actually 5/6. What else can we do? Well, let's see what the graph of this looks like first. 10 comma 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 9, 3. Here's 9. 1, 2, 1, 2, 3. -2, 4/5. Now let's do this here. And where x is 8, okay, you can't have that, but I'm going to put a little dashed line because you can get anything up to that, I believe. -2, 4/5. -1, -2. 4/5 is what? Right about here. Let's put a dot there. -4 was what? 5 something? What did I have? 5/6? Something like this. We probably need some other numbers. Let's go a little farther over here. What number could I put that's over here? What was this? This was 10. Let's go 12. If x is 12, I get 12 minus 8 is 4. 2 over 4 is a half. Half plus 1 is 1 1/2. So 10, 11, 12 was 1 1/2. Get this. Okay. Now, what you will see, step this way up. And then let's get a dot right here. What happens on this side over here? What if I did 7? What's 7 minus 8? Negative 1. 2 over negative 1 is negative 2. And negative 2 plus 1 is negative 1. So 7 gives me negative 1. Right here. Now, fill it in the blanks. Let me just show you what you're always going to get when you come across these types of equations. When you get a fraction that has an x on the bottom and a number over here, you're always going to get something that looks like this. This is a little curve here, okay? And this line is going to shoot straight up like this, and it's going to get awful close to this 8 that we talked about, but it'll never cross it, okay? This other line here is going to do the same thing with this line right here at 1. It's going to get awful close to it, and it's never going to cross this 1 line right here. So you get this little swoosh right here. On the other side, you get the exact same mirror image of that. In other words, it's going to look like this. See how this, our two lines that we're approaching but never crossing are this one. I should have done it in different colors. My other line is going to do that same thing. It's going to go like this, shoot down, and come like this. Okay. This, if you wondered why we call this asymptotes, is because of this. These two dashed lines that this graph approaches but never crosses are called the asymptotes. Okay. There's always a horizontal one, and there's always a vertical one. And in this case here of this equation here, my horizontal one was at y equals positive 1, and my vertical, my up and down one, was where x was 8. That graph will come close to those but never cross those. Now if you understood that or not, it doesn't really matter, because we will talk about it right here. Ready? Just like with linear equations, we had stuff that looked like this, where they gave you a generic form of that. There's a generic form of this, and it is, as soon as I can find it, y equals a over x minus b plus c. Y equals a over x minus b plus c. That's the generic form of this rational number thing that we're talking about today. I don't know if it has a specific name. Okay. Now let me ask you a question. Would this y equals 1 over x be classified as one of these things up here? In other words, could you give me the A, could you give me the B, and could you give me the C from this thing here? What is my A? A would be the top of the fraction. What is the B?
0.
Right, because this would be x minus 0. And what is the C? 0. So yes, this is like what they call the parent of this. This is the very basic form of that. But a lot of times they'll be given like this. So here is what you need to know. And this will clear it all up. If you didn't get any of this, this is all you need to know. The vertical asymptote is the vertical asymptote. Let's go back and look at this other picture here. The vertical asymptote here was where x was 8. Why? Because 8 made this fraction undefined, not 0, because you can't have a 0 on the bottom of the fraction. So whatever number x is that makes this 0 on the bottom is going to be the vertical up and down line that that'll come close to. The way the book says it, which is a little confusing, okay, the book says it a little confusing. It'll say the vertical asymptote is, I believe, negative b. Let me look for it here.
So is it just B?
Well, it's not b, it's negative b. It's the opposite of what b is. Okay, because if b, like in the last one, it was x minus 8. Okay, if I said it was b is negative 8. What's a negative 8? A negative 8 would be negative 16. It has to be the opposite of the letter b. just think about it as whatever makes the fraction 0. Whatever makes the fraction 0. And when we do the examples, it'll all come up. The horizontal asymptote. How did I spell that? Guess why? Tote is C. In other words, whatever number follows the fraction there, that is where the horizontal line would be when you graph it, that graph would approach and not cross. Again, examples will make this completely very easy for you. For example, if you have y equals 2 over x plus 4 plus, 3. If you are supposed to graph that, you need to find the vertical asymptote and the horizontal one. So you ask yourself this question, where will the fraction be 0? What number? That's the x one. Nikki Calla?
-4.
-4. So here at -1, -2, -3, -4, you draw a dashed line straight up and down. Because that is the vertical line that this graph is going to approach but never cross. The second line is the horizontal line, the horizontal asymptote, and that is at +3, which means here at 1, 2, 3, you put a dashed line. Okay, and then rather than plotting the points, you don't really need to plot the points because it's always going to look like this. It's always just going to do this. It's going to go wham like this and boom like that. That is going to be the graph of it. And it's always going to be the, write this down, it is always the upper right and lower left. I can't write it anyways. It's always upper right and lower left. Unless something's negative, I should probably check and see if it switches. Does it switch when it's negative? Maybe they don't give us that yet. I don't think they give this yet. And I don't know if it switches. Nick?
Wait, so we don't have to graph the points?
No, you don't have to plot any points, it's just gonna look like that.
Yeah, but
Nick is wondering, let's just do this right here. Okay? If x was 0, if x is 0, if I did this right, if x is 0, then y should end up being what? 1, 2, 3, something bigger than 3, a little bigger than 3, probably not 4. If I put 0 in here, what's 0 plus 4? 4. 2 over 4 is a half. So y equals 3.5, which is really what I've got here. Here at 0, it is about 3.5, because right there would be 4. And you just know that it's going to come, it comes and makes that sharp thing. And the farther and farther out, the closer I get to this 4, the smaller, or the closer it gets to that line, but it'll never ever get there because you can't have that. Isn't that amazing? Shocking, exciting. So if the equation was y equals 1 over x, what would be the graph of that? Well, x can't be what? X can't be 0, which is this. Okay. The y value would be 0 because it would be plus 0. So you'd have the horizontal asymptote would be that, and the graph of it just looks like this. That is the basic thing. Now the difference, the numbers that you put here just make this whole thing shift whichever way you put the numbers there. Lucas Spaniel?
Could you do it the other way? Like 1 at the top or left hand corner and then the lower right hand corner?
Could I? No, because it won't work that way. Give me numbers that would do that. You give me a number that's going to fit in here somewhere, which would have to be, in other words, you'd have to pick a negative x value that gives me a positive y. And will that ever happen? No, because as soon as you pick a negative number for x, that makes this whole thing negative.
Is there like a
What if
different
there's a
math
negative
equation for?
What if it was a negative 1 on top? I don't know. Maybe that's what would happen. Maybe it's the top number is negative, it switches sides, does it? I'm looking here in the book because we don't deal with this very often. Let's graph that. I'm gonna do that. Y equals -1 over x. We should still have the same asymptotes, right? You would think it would change it. Maybe that's the answer to the problem, Nick. So if I put a, what, -1 in for x, y equals +1, right? So here at -1, it must be, if this number is negative up top, then that changes, I guess, the sides of the graph, and it would look like this. Where that's coming from. But they won't. I don't see it. I think they're assuming that the top number is always going to be positive. So there, we learned something today. Alright, so you graph this one for me. Y equals 5 over x minus 3 minus 2. Just sketch me the graph of that. Sketch me the graph of that. Sketch me the graph of that. And again, on a quiz or a piece of paper, I would need to see both the horizontal and vertical asymptotes. And then the rest of it is just a sketch. It's a little sketchy. So you should be done, and it should look like this. Here at +3, you should have a line that goes straight up like this, a dashed line. Because it's whatever makes a 0 on the bottom. The vertical or the horizontal one should be at -2, which looks like this. And then the graph of your line, as long as this top number is positive, should look like this. Questions? Did you get that? So I'm going to give you a worksheet that has that on it.
So basically, the A doesn't matter, so
The who?
the A doesn't matter.
No. The A just, if you think about what this top number would do, it would just change maybe how quick or how slow it gets closer to that axis. It really doesn't change a whole lot. We could probably do a graph and see what it is, but that's not.